So I think there's about a 25% chance that your AP/BC test will include one of these problems, where you need to recognize this logistic differential equation, and they ask you to solve for y using separation of variables. We know that if this is the differential equation for a logistic, the solution will be of this form, where the maximum is in the numerator and the maximum is 1,000, and k is 1/10. And then the only work you'd have to do is to find c using some given x and y value, or some given t and y value. But I think about 25% of the time they ask you to actually solve this diff-EQ using separation of variables. And if they do that, this is where you can really do well relative to the rest of the nation, because most of the nation doesn't do too well on this problem. All right, let's go through that process one more time. The factor y and the factor of this difference are both functions of y. We will get them on the left side with dy. Next, we'll take the integral of both sides. The right side of this equation is really easy, but the left side is difficult to anti-differentiate. We need to first rewrite this fraction using fraction decomposition. We're going to rewrite this fraction as a sum of two fractions. Next, we're going to multiply both sides of this equation by this denominator. So on the left side of the equation, this will divide out by that denominator, leaving us with 1. And on this side of the equation, when we multiply by the first term, the y in the denominator will cancel out with the y in the numerator, leaving us with just 1 minus y over 1,000 times a. And then when we multiply it times the second term, this factor will cancel out, leaving us just with y times b. Recall that we now choose y values, which will make each term cancel out by being 0. So let's let y equal 0 first. Substituting a 0 in for y, we get 1 equals 1a plus 0. 1 is equal to a. And now we're going to find what b is equal to for this partial fraction decomposition by forcing this term to be 0. So what value of y will make this difference 0? 0 times a is 0 if y is 1,000, because then we have 1 minus 1,000 over 1,000. 1 minus 1, 0a. And we'll be able to find y. And substituting 1,000 in for y, we could quickly see that b has to be 1/1000th. So we're ready to finish the integral step. We are currently here in solving this diff-EQ. This side was equal to this side, which was 1/10 t plus c. And now we're going to rewrite the left side. So this integrand is decomposed into fractions, and the a value we figured out is 1. And the b value we figured out was 1/1000th. Remember, we are solving this differential equation. We've separated variables and done partial fraction decomposition, and now we're here. All right, rewrite these fractions in this way. Distribute the 1,000. Which simplifies that a bit. And then let's do the integral of each term separately And we're ready to roll. So the antiderivative here is a natural log of the absolute value of y plus some constant. I'll call it a different constant than this one, c2. And then plus the antiderivative of this, which is the natural log of the denominator. But notice you need to use the chain rule. If you went backwards and took the derivative of this, it would be 1 over 1,000 minus y times the derivative of the inside with respect to y, which is -1. So we need this negative sign out front. All right, let's subtract our constants from the left. We'll subtract those constants from this constant, getting a brand new constant. Let's just call that one c. And remember, this is a subtraction because of the chain rule. If that wasn't clear to you, try a u substitution where u is 1,000 minus y, then du is -1 dy. And when you see the substitution, it'll be clear to you if it wasn't already that this had to be subtracting. All right, so the natural log of 1,000 minus y, we're going to put our variable in front, y minus 1,000. Since we're taking the absolute value, it's the same value in either direction when you subtract on the inside. Now we will rewrite our difference of two logs as a single logarithm. There we go. We could write that fraction on the left as one big absolute value symbol, but it's equivalent. Next, we will get rid of log base e by doing the inverse function, the exponential function base e, to the left side and to the right side. And then all we're left with is the absolute value of y over y minus 1,000. And that's equal to e to the t over 10 multiplied by e to the c. Well, e to the c is some constant raised to some constant, so we can just say that that's just some constant. Can't be equal to this constant though, so let's say this one was c4, but that's not really important. So e raised to some constant, constant 4, is equal to some new constant, which we'll just call c. Okay, so now we have this, and remember the absolute value means the distance from 0. So whatever this is, this expression's distance from 0 is this value, which means it might be positive or it might be negative. We just know that its distance from 0 is this distance. Therefore, since it could be positive or negative, in algebra we normally do this, or I should say in Algebra 1 class or Advanced Algebra class, if we were solving the absolute value of something is equal to 3, we would normally say that means x is positive or negative 3. And the reason is if the distance away from 0 is 3, we could be at 3 or negative 3. That's why you can go from an absolute value equation to one without, but with positive or negative. But since c is just some constant, it could be positive or it might be negative. So we actually don't need the positive or negative symbol or the absolute value symbol because c itself could be either positive or negative. So we'll rewrite this without the absolute value symbols. So there it is, and then we will solve for y. So we'll multiply both sides times y minus 1,000. Multiply this factor and distribute it. Collect all of our y terms on one side. Factor out the y. And then divide by that factor, solving for y. All right. We've solved for y. We've done it. We've solved for y. But we're going to go ahead and get this into the real nice, recognizable form. So we're going to end up with our numerator being just 1,000. So we're going to divide by this entire factor here on both the top and the bottom. In other words, we're going to multiply by 1, thereby not changing the value of this entire expression. 1 in the form of this over itself. And now in the numerator, this denominator and this numerator will cancel out, leaving us just with 1,000. And in the denominator, we have to distribute it. So first it gets multiplied by the 1. And then it gets multiplied by minus this times the red. So this expression minus this -1 is +1. Then 1 over negative c, that's just 1 divided by a constant, which is itself a constant. So we'll call it a new constant, constant b. And there we have it. Well, not quite, but we basically have it. We have the maximum value over 1 plus some constant times e to the -1/10 times t, where 1,000 is the maximum value and 1/10 is k, because the form was the maximum value over 1 plus some constant e to the -kt. So if we didn't have to solve it with separation of variables, we could have went straight from the diffie-q right to the solution for y. But if they ask you to solve with a separation of variables, then we're going to have to do all that work. And we still have to find b. All right, number 6 does say, in an isolated town of 1,000 inhabitants, 100 people have a disease at the beginning of the week. So what they're saying is at time 0, there's 100 people with the disease. So we can use this information to find the constant b. And e to the 0 power is 1, so we have just 1 plus b in the bottom. And solving that, b is 9. So our final answer is y is 1,000 over 1 plus 9e to the -1/10 t, using separation of variables.